Here are the answers to questions 1 through 3 for the normal force elaboration video plus worksheet assignment. So, I'm sure you don't remember, but here are questions 1 through 3, and I paraphrase them a little bit. So number 1 is, what is the normal force and when does it occur? What is the normal force? Number 2, why is it called the normal force? And number 3, draw a diagram to show why the normal force is always a push. So these questions, the exact answers were given in the video. So if you paid attention during the video, you should have been able to answer these. So here are the answers. What is the normal force and when does it occur? It is a pushing force that occurs whenever two solid objects touch each other. So this idea, they have to be solid objects. Anytime two solid objects touch, there is a normal force. So why is it called the normal force? I've actually emphasized on multiple occasions why it is called the normal force. And it's called the normal force because the direction of the force is perpendicular to the point of contact. So this is a mathematical term. Perpendicular is also called normal. It's mathematical. So several of you who are not listening, several groups, it is not because it is a natural force or common force. That is not why we call it the normal force. Normal means perpendicular. Hopefully by the end of this video, you will never make that mistake again. Okay, last thing, draw a diagram to show why the normal force is always a push. So pretty much anything with electrons repelling each other would have been good. So if you watched the video from Vsauce Michael, why you can't touch anything, really important video, only need to watch about the first 3 minutes of it. If you haven't watched it yet, watch it. If you've watched it and you're still confused, watch it again. All right, so now we're gonna have fun with answers. So we're gonna go through some answers that people put to see what we think. So answer to the first question, normal force is when the electrons from two different objects, atoms, repel each other. Normal force occurs whenever two objects touch. Yep, I think this is actually perfectly fine. And so good job, group. So normal force occurs when two objects are touching. So that is a great answer for the conditions when it occurs, but I would also like you to indicate that a normal force is a pushing force. Number 3, the normal force is the reaction that the object gives back after a force is put on it. The conditions are that some force has to be applied to the object to have a normal force. So the thing that concerns me is that people may have understood what they were talking about, but when they say that after a force is put on it, the question is, where does this force come from? Same thing. Some force has to be applied. Where does this force come from? It's really critical to realize that forces are interactions between two objects. So forces are interactions between two objects. So interactions equals force. And so when you say after force is put on it, I'm not sure that you really understand what force means. There are two objects. And so it's when two objects interact that a force occurs, an interaction occurs. There's no force independent of two objects. So a normal force is a force that objects exert on other objects. Their electron clouds repel and push each other so they do not touch each other. The conditions of normal forces is that the amount of force pushing down on an object is the same from the other object pushing back up. So the only thing that concerns me about this answer is that they've put in directions. So they've talked about pushing down and pushing up. And it's really important to realize that normal force can go in any direction. So if I have a surface here, so here's a surface, and an object, so we'll say like a ball, comes, and hits the surface. Okay, so when it hits the surface, so there's a normal force that is exerted perpendicular. So perpendicular, that means this is a right angle, and the surface exerts the normal force. So this is F normal on the ball by the surface. And then we can also say that the ball exerts a normal force. So there's a force normal on the surface by the ball, but both of them are at right angles at the point of contact. Okay, so that's the only thing about this answer that concerns me, is just they're giving a direction. Normal force is not always down or up. Okay, so normal force is the force that pushes back against an object when it gets close to the surface of another object. Nice description. The conditions for this to happen are when the atoms of both surfaces get close enough that they start to repel each other. Normal force is any outside force that causes a push or pull on an object. They occur when numerous objects or weight forces come in contact with each other. Okay, so again, I'm deeply concerned that the people in this group, if this is you, please listen up. A normal force is any outside force. Outside of what? I'm not sure what that means. And then numerous objects, not required. You only have to have two. Normal force is when an object pushes another away when the electrons repel. The conditions are that two objects must be close to touching so the electrons in the clouds can repel. Okay. The normal force is the push back of an object to another force. This occurs when an outside object exerts a force onto another object. Okay, so I wasn't too sure about the first part of the sentence. Normal force is the pushback of an object to another force. That's a little unclear, but the second part, it makes it, I've got object one, object two. No details, though, about its electrons repelling. A normal force is when two objects push against one another, and this occurs when electron clouds compress to repel one another. Okay, so we assume that objects are solid, and so this one works. All right, question 2. Why is the name for the normal reaction force normal? Yes, people were listening. Perpendicular. Thank you. They're called normal forces because they happen around us all the time. Sorry, this is thumbs down, not why they're called normal. Please learn why they are called normal. Because it is a force that we do every day and happens with ordinary objects. Again, please listen up if you put this or if you think this. This is not why it's called normal. It's called normal because normal means perpendicular, and it's perpendicular to the point of contact of two objects. Because it happens whenever objects touch, and that is the normal state of things. Nope, sorry, not what normal means. Normal means perpendicular. Perpendicular. Whoops, my line is not straight. Okay. Perpendicular. That is normal. Normal means perpendicular. It's geometry normal, as in perpendicular, because a normal force is always perpendicular to the surface being acted on. Nice job. Give yourself a pat on the back if this was your answer. Because the normal force is happening perpendicular to the force of contact. I think they meant point of contact. We're going to assume that because they remembered perpendicular, they also knew that was point. Good job, people. Normal force is also called reaction force because it describes an object's electrons' reaction to being pushed away. An object's electrons react to another by repelling the other object's electrons away. Okay. Nice description, but doesn't say why it's normal. Normal means, you got it, perpendicular. Gonna draw it again. That's what normal means, perpendicular. Okay. So, perpendicular, right angle, right? It's called a normal force because the repel or reaction is a perpendicular push. Awesome. I'm gonna even write awesome. Oops, I'm gonna spell awesome correctly. Because it occurs when any objects push against one another, so it is common or normal. No. Nope. Now I'm getting silly, sorry. Sorry. Normal means what, people? Means perpendicular. Perpendicular. I'm going to start drawing this differently. Let's change the direction. Perpendicular, okay? It's a natural reaction to an outside force. What do we think? Nope, you guys got this. We know it's perpendicular. Let's draw another one. Okay. Sorry, it's hard for me to draw in this direction. Okay, perpendicular. That's what normal means, perpendicular. Yay, we've got another one. Because every object has this force. Nope. Sorry. Not what normal means. Normal means perpendicular. So let's draw one like this. Perpendicular makes a right angle. It's normal because it is supposed to mean perpendicular to the surface. Yay! Good job, star. All right, let's do a weird one. So suppose we have a curved surface. Okay, curved surface. A perpendicular can be, so we just kind of eyeball what would be perpendicular at that point. Perpendicular. Okay, hopefully that was enough that you will never make that mistake again. If you did, normal means perpendicular. Perpendicular to the surface at the point of contact. So if I have a ramp like this, okay, and there's a block on the ramp, the perpendicular, I've seen multiple people make this error in their drawing. Perpendicular goes like that. Perpendicular, okay, right angle. So if my ramp is tilted, my normal arrow is tilted. Okay, draw as many diagrams as necessary to show why normal forces are always pushes. Okay, so this person didn't, or this group didn't really talk about electron clouds, but they seem to get the idea that they're pushing away, but it's because of electrons, okay? So these people also repeated a diagram, which is fine, as long as they realize that these circles, those are electron clouds. So if you realize those circles are electron clouds, awesome. Okay, so these people didn't show why, okay? And it's about electrons repelling each other. And so they put forces on, but did not say why, which is electron clouds repel because negative or like charges repel each other. This group, nothing on it, not sure. This group, oh, the hand is pushing onto the wall and both of their electron clouds are pushing each other to keep them from touching. Awesome. Okay, this one. The electron clouds on the table are repelling or pushing the electron clouds in the bowling ball to keep them from touching. So again, let's do like a yellow. So yellow. Nice job. these are nice drawings, and I'm thinking I'm understanding what the people are saying, but because they read the tension or saw the tension force one, that if electrons on atoms, like in a rubber band, are too far apart, then the rubber band will pull back closer together. But I'm not really sure what to think about this one. So if they're too close, then they push each other away to get farther apart. So this, like I said, a lot of work on the diagram, which is nice. It would have been helpful to have a little bit of writing to explain it. So. Okay, so in this one we show Newton's third law pairs of normal forces, but again, which is nice, but again doesn't answer the question of why they are always pushes. And so that's because it involves electrons repelling each other. Okay, so we've got electrons. Not exactly sure what this line is. There is no such thing as atomic saran wrap that keeps things in, so I'm not sure what this line is or this line. Not sure what those are, but electrons definitely repel each other, so nice job. Okay, so these people use the spring, which is nice. Again, it would have been good to put in some dialogue, like the electron clouds or the spring is analogous to the electron clouds or the springy atomic model, but you know, at least you're kind of getting an idea, but you need to pull in electrons. Okay, I love this one. They show like atoms. They show going sideways. And so this was awesome. So. And again, this was really nice to do like a close-up of what's happening here, that there's repelling going on. Again, I would have liked just mention electrons, but good job.